Okay, so the first application problem of integration is the area problem.
Chapter 5.1. Calculus.
December. You must have heard about area under the curve.
Yeah.
Statistics.
I mean, we see it all the time.
Right. So let's say 2 to 4, and I will call the height to be 3.
So now we're including geometry.
Sort of. Well, at least I guessed it. Now I want to find the area of the shaded region. What is the area of this shaded region?
2, 4, 3, 2, 6.
Geo,
Huh? Was that right?
what did you say?
Length times width?
Wide length times width.
That's just the area formula. I mean, that's the area of the thing.
What thing?
Of the
It's a rectangle.
Rectangle. So that is a rectangle. So the area of a rectangle is length times width. So width, length, doesn't matter.
Oh, that's a 3. Up on the 2.
If I multiply those two, 2 times 3, I get 6. So the area of that shaded region is 6. Now that is a piece of cake. Great. I want to find the area between 0 and 4 under the curve. I'll tell you that that is 5. Not that it matters. Can you tell me the area there, the shaded area?
No, without the concepts we're about to comment.
With numerical accuracy? No,
No,
no way. Why not? What made it different?
No shaders.
It's bending.
It's bending. Right. Yes, it's true. It is a curve, right?
It's not a
It's got
classical shape.
multiple bends. That is actually a function. Yes, I could call it f of x. Good. So here it was easy, even at this step, this was a function, f of x. And I simply multiplied the value of the function, which is 3, with the length that I had over here, correct? And I got the area. So I can extend the concept to this particular curve and try to find the area. And want to use that one, I'd rather use this one. Let's say this is y equals x squared. Parts of a parameter. The interval is 0 to 2. And I would want to find the area under this curve. In other words, that shaded area. That goes, it's a curve, has bend, not very accurate to find. So what I can do is divide that interval into a specific number of subintervals. So length of the interval is 2, yes? Called delta x. Delta x is b minus a divided by n. B is the upper limit, a lower limit, and number of subintervals, I'll call it number of rectangles. I will connect the dots.
And n was equal to number of rectangles.
Yes. So for this example, I am going to consider n to be 4. So delta x will be 2 minus 0 divided by 4. Two over 4, I get 1/2. Yes,
Why did you pick 4?
just because I
So,
want
right,
random. We will get to that soon.
okay.
I picked 4 because I just liked 4.
But did you say that delta x exactly like represent?
Length of the subinterval.
And the more rectangles you have, the more n circles.
So, in other words, I just have to move from 0 I have 1/2 delta x, right? If I take another step, where would I go? 1. Another step. Good. Those are the endpoints. Now, what I'm going to do, start from the right-hand side. So I'm going to pick the right endpoints. So I'm going to start here, go all the way up to that point. Do I have a rectangle?
Yes.
Yes. Start there from the right hand side.
I did 4.
Do I have another rectangle? Go that way one more time. Do I have a rectangle? And lastly, I'm just going to do that. Good. Somehow, these rectangles do contain the area under the curve. Do you agree? Yes. If you look at it closely, you've got the area there, area there, area there, arms there. I got the area under the curve. But is it accurate? No. Why not, Annie?
Well, because you only have partials of the rectangle.
Right, so in this case, am I going wrong by estimating too much or too little?
Too much.
Too much, because the actual area is right here, and each of these rectangles, there, give us extra amounts, so we end up having extra area. Now, how do we find the area of each of those rectangles? So. Delta x1, delta x2, delta x3, delta x4. But in this scenario, the deltas are the same. Do you agree? Yes, no? I picked the same value because I want things to be easier. So why did I call it x1, x2, x3, x4? Each of those endpoints correspond to x1, x2, x3, x4. Good. So, in finding the area of the rectangle, I've gotten the length part, just like the previous case. And I made it easy on myself by making sure that the deltas are the same. Of course, could you use different deltas? Well, certainly you can, but we're not going to. All I need now is the height of the rectangle. Yes. What is the height of the first rectangle? Which is right from here to there. How do I find that height?
Plug it into the question.
Why, Gio?
Because it's a function.
Because from here to there would mean you go from the axis up to where the line touches the function, correct? So that should be the y value of the function that is going to give you the height with me. So if I plug in 1/2 in x squared, that would be 1/4. But I'll do that in a bit. So I'll call it f of x1. F of x2. F of x3. F of x4. Yes. Now, the area under the curve, based on the construct that I have, I could write it as delta x1 multiplied by f of x1 for the first rectangle. Yes. Delta x2 plus f of x2 for the second rectangle. You have to take a guess. What is the next?
Delta x3 minus f of x3.
And correct. But I made sure that the deltas are the same so that life is easy for me as far as this problem is concerned. So the delta xr, x1, x2, all of those would simply become delta x f of x1, delta x f of x2, delta x f of x3, delta x f of x4. I've made them all the same. Yes. What do I have in common? Delta x. Going to order out.
Wait, so isn't each one of these has at least delta x of one, or delta x1, delta x3, delta x4?
They're all the same. in this example, they are delta x1, delta x2, delta x3, delta x4. But I have divided,
Because they're
defined them.
equidistant.
Yes, because I made them the same for the sake of convenience. Yes. This delta x is always the same, and we know what that is. B minus A divided by n. Correct? F of x1 plus f of x2 plus f of x3 plus f of x4. Correct? So I got a formula for that area. Now, I picked n to be 4. I will write this as 1/2 in a bit. N was 4, I had 4 different endpoints, and I had a common delta x, which I pulled out, and I end up having this formula. But if I want to extend this to an arbitrary n, instead of 4, let's just say 10. How would this formula change?
You have to do 10 more, that's what.
Right, all the way up to 10. How about 100? All the way up to 100, right? Would this part change?
No.
It will always be b minus a over 10. So, I'm going to write this as b minus a divided by n. Do you really want to write this as f of x1 plus f of x2 plus all the way up to 100?
No.
No. Got to be effective. Sideways L, I call it, or sideways W, depending on how it's done. That means sum. You are summing all of these values, starting at 1, all the way up to whatever n is. Correct? And I'll just put this as f of x. Good? With me so far? I want you to write that for me. We're going to call it as R sub n. Any guesses as to why we call it R sub n?
Is it something to do with geometric or arithmetic now?
No.
Right.
What?
Right.
Right what? I know I'm right all the time.
The right point of the.
So if we looked at our sketch, we looked at the right endpoints, right? We started from the right hand side. So that is the formula that's called the right sum. And then we'll have the wrong sum. Bad joke.
The f of x, is that a 1 or an
I.
I?
It's not the wrong sum. The other one, if you have to take a guess, would be left sum. Okay.
Sad thing is we have to pick a side at all.
Okay. You don't have to, you can be right in the middle. So before we get to the left sum, let's evaluate and find an answer. So b minus a over n is 1/2. Yes. Evaluate f of x1, which is simply y equals x squared, evaluated at 1/2, correct? Which will give me 1/4. Evaluate y equals x squared at 1. Evaluate y equals x squared at 3/2. 9/4. evaluate y equals x squared at x4, which is 2, to get 4. So that's 5 plus 10 over 4, 30 over 4, which is 15 over 4. No, 5. Yeah, that's right.
Thing is, though, there's also some counting.
Great. Alejandro asked me, well, doesn't this include the red bits over there? Does it?
Yeah.
Absolutely. So earlier, we agreed that this is estimating too much of the area. So this is the overestimation of the area. Good. So I will call this R4 for example. That's value 15 divided by 4. So, okay, this would be x0. That's where I'm starting. So x0
X1 half.
awful line.
I mean, it doesn't exactly matter. You know, so it's more
To
just.
you, it doesn't, to me, it does. Right, so x4, then x3, x2, x1. Yes. Now, the same concept, delta x1, delta x2, delta x3, delta x4, very similar to that. And what did I do in order to make it easy on myself? Or
Oh,
So is delta x not always the same number?
doesn't have to be. I'm making it to be the same so that like say,
How would it not be the same?
what?
How would it not?
I could set this to be 0.25, 0.75, 0.1, 0.8. I don't want to do that. No. I started from the right hand side over there. Here, I'm going to start on the left. So left endpoint that way. Left endpoint that way. Left endpoint that way. Left endpoint that way. Yes. There's no area here. Over. If I sum the rectangles, that would be my area. Do we agree?
so we're.
Now, in this case, did I overestimate or underestimate the area? I underestimated because the actual area under the curve is bigger than the shaded area that I got from the rectangles. But this would be the left side. Just like R4, this is L4. 4 comes from the number of rectangles. Using the same formula, it would be B minus A over N. There is only one difference. And what is that one difference? Here, it was 4, 3, 2, 1. Over there, In this case, what would I do? The first one, that's the height, which is 0. F of x0, x out 0. The next one would be f of x1. The one after, f of x2. One after that, f of x3. I want you to look at the formula that we wrote previously for R4 and tell me what is different between R4 and L4. Of course, the letter R and L are different. Yes.
So back to instead of this one, we start from 0 and the other one we start.
Got it? So here, this starts at 0. Previous formula, it started at 1. But there is another difference.
This one stops at 3 and the other one stopped at 4.
This one stops at 3, the other one stops at 4. So I have to write that formula. All I have to do is change it 0 to n minus 1.
Oh, that just means where you're starting.
Right sum, not right sum, left sum. Yes,
Do you always start from 0 when it's left and always from 1 when it's right?
you start from x sub 0, not from 0. Suppose I had a shifted curve, the very first point on the interval will be x sub 0. So it's a good question. The 0 does not come from the 0 on the axis. It rather tells me the point where you start.
For the very first point on the
Very
side.
first point. And xn would be the very last point. Is it?
So if you overestimate, use the right sum, and if you underestimate, it's the wrong.
Yes. Now, clearly, this answer better be less than 15/4, or else my life would be meaningless. Right? It better be. It is going to be. I would actually bet my life on that. So, what is the value of f of x 0? 0. What is f of x1? 1. So the area of that rectangle would simply be the height 1 multiplied by the width. Accounted for this already. 1 squared, 1. The second point is x2. What is f of x2? Shouldn't listen to Geo. x1 is 1/2 squared, which is 1/4. x2 is 1 squared, I get 1. x3 is 3/2, so plug it in the function. 3/2 squared, which is 9/4. Yes,
So you're using the same values from the first bar.
exactly.
Except for 1, but we're starting.
So instead of going from x1, x2, x3, x4, I'm doing x0, x1, x2, x3. So 10/4 plus 1, 14/4, 7/2.
How come when you did that one, it was 30/4? And then when you multiply it by 1/2, you got 15/4, but this one is over 2. Do you think so? Oh, okay. That makes sense.
I can write it as, anything I want. So L4 is 7/2, right?
Wouldn't it be 7/4 instead?
7/4, why? Ah, yes. 7/2, 7/4. So L4 is 7/4. R4 is 15/4. This is clearly underestimating. That is overestimating. Now, by all means, the actual area under the curve must lie what? In between.
Also, that's a piece subtract the over.
Force that are equal to each other.
We will get to that in a bit. So the actual area must lie between the left sum and the right sum. Now, in this problem, I picked 4 conveniently because I just like the number 4. It is going to be easy on me. But it's not giving me the accurate answer. What will give me a more accurate answer? Maybe the left or right sum doesn't matter, but I just want to make it more accurate. So what should I do? What would happen if I increase the number of rectangles? Would it become more accurate or less accurate? More accurate. More accurate. So, where's this? That is my left sum. That is the right sum, right? Ln, Rn. If I increase the number of rectangles, I'm going to get better estimates, right? Under what condition will I get the exact area under the curve? If I have to use infinitely many rectangles, right? How could I draw infinitely many rectangles?
You shaded it completely.
Huh?
You shaded it completely, not even.
You shade everything completely.
It'd be a
So-
solid black.
Let's see if we can connect the dots. Between this unit and unit 1. What should I do so that I would have infinitely many rectangles? Take the limit. Take the limit on both sides.
What?
Mind blown.
You're asking how it'd be for visual representation of it.
Right, if I took the limit, then A would equal Rn. And the same here when I take the limits, A would exactly equal Ln, right? Otherwise, it is going to lie in between. With me. So you increase the number of rectangles, the more accurate the area is going to become. Now, instead of using the same delta x, which I did it for the sake of convenience, right? If I changed or used different delta x values, I will have delta xi f of xi Correct. Yes? I equals 1, 2, n. Yes? That sum is what we call the Riemann sum. So, of course, the left sum, right sum, both of them are Riemann sums by default. But if I pick arbitrary xi's and arbitrary delta xi's, in other words, not necessarily equally spaced intervals, that would be the Riemann sum. And if I take the limit, I would end up getting the area under the curve. In short, the limit n approaches infinity of the Riemann sum is the area under the curve, as long as the curve is continuous and specifically differentiable, because if it is differentiable, then it is continuous. Do we understand the concept?
Yeah.
Yes? Yeah. So we have f of x equals 2 plus sine x. And of course, what is the first thing that you should graph it? It probably is going to look like this. So what is delta x? Delta x is a minus a divided by n. So pi minus 0, I know this one divided by 4.
Meaning by
Pi. Good. So what is x1?
by
4.
no, like the. Wait, no, yeah.
Technically, it should have a better peak. I just drew it this way. Okay, let's find the right and the left sum. And tell me what you get.
Just thought maybe I wasn't.
Oh, we change the area entirely. So that's not a 2, that's actually a 3.
Yeah.
Because sine pi over 2 is 1 question.
It's the 3 now?
Well,
It
it
has always been 3. I just made a mistake.
should have started too.
You can't say technically after James pointed out.
I just thought it was an artistic rendition. Once you put it in the calculator, you're gonna find out that it starts at 2.
True.
Or even just by looking at the equation.
So it will start at 2 because when you plug in 0, 2 plus sine 0 would be that.
I mean,
That's not going to have an effect on the answer there, right? Because you're simply using the original function.
That's why I was set to do.
Well, so in a way, that mistake I made should have revealed something that goes back to what Brianna asked me earlier. Should that always be 0? Not true, right? The y value here could be anything, but the x value in this problem is 0. the x value here, x1 is pi over 4. x2 is pi over 2. x3 is 3 pi over 4. The last one, x4 is simply pi. Now, things wouldn't change in terms of the formula just because it's the wrong graph, because we're simply going to plug it in the original function. So the left sum formula
I think it's the same.
is delta x sum, where should we start? 0 to 3, f of xi. Delta x is pi over 4. Plug in 0, which is x0. 2 plus sine 0 is 2. Plug in pi over 4, pi over 4, sine pi over 4, root 2 over 2, which you can write it as 1 over square root of 2. So 2 plus 1 over square root of 2. When you plug in pi over 2, you will get 2 plus 1, 3. Yes. Lastly, 3 pi over 4, that is in the second quadrant, sign still positive. 2 plus 1 over square root of 2.
So.
Good.
2 plus.
So 2 plus 2, 4, 7, 9.
Oh, okay.
9 plus 2 over square root of 2. Which is simply 9 plus square root of 2. You can use a calculator. But that is helpful. Did I look good?
I didn't pick.
It still doesn't work out. The calculator makes sense.
Huh?
The calculator wasn't exactly giving me that value.
Yeah, they are the
You didn't
same.
notice?
Both are looking.
So if you start from the right side, sine pi would still be 0, right? So you have pi over 4. We're just evaluating sum I equals 1 to 4 f of xi. So you're going to start from these values and you would add 2 plus sine pi, which is 2, right? So 2 plus 1 over 2, root 2, plus 3, plus 2 plus 1 over root 2. The last part, when you plug in pi, you would simply get 2 again. So in this case, left sum, right sum became the same. So no overestimation, no underestimation. Do we know why?
Because it's perfect. When you try to do it like manually to draw it out, it's like kind of perfect.
So if you drew it here from the left and the right, the rectangles would look exactly the same. Yes, it's not going to go out, it's not going to go under because of symmetry. So one way of doing, now there is another case called midpoint, or using the midpoints to find the area. If you have to take a guess, how would we find the area using the midpoint?
You divide by 2.
Divide by 2.
Add the, it's like that right side, left side, and then divide by 2.
And that's what he said.
That's what it just said. Is that true?
Huh?
Is it right or wrong?
No.
Oh, man.
uh,
Big percentage.
I don't think so. No, my left is the same.
So- The midpoint, rule. Come back again in Simpson's rule and trapezoidal form later on, but what do you think the midpoint will use?
Something to the left and the right, and then try to find something to the left.
What should the midpoint rule use? You have to take it again.
The middle.
The middle, right? The middle of each rectangle. Yes. So you can simply do M4 as delta x sum I equals 1 to 4 f of xi star, where xi is not the endpoint, but rather xi star is actually the midpoint between those 2 points. So you can use the midpoint to find the area as well. The only difference here would be, instead of using the endpoints, you would simply be using the middle values. Yes. Probably clear. No, why not?
Do we necessarily need to use midpoint for anything?
I think that's what I checked. So WebDesign does have midpoint. So, Andy, what do you want?
So you just start from the middle and then go to the left or go to the right?
So the midpoint between 0 and pi over 4 is pi over 8,
Oh,
right? You do the same over here, pi over 4, pi over 2, divide by 2,
okay.
same thing. And you would use these points to plug it in the area.
So does it matter if you start from the left or the right?
Doesn't matter. All you care about would be the midpoints of the rectangle.
Oh, okay.
Good.
Would that be more